Every time you stream a movie, store a file in the cloud, or run an AI model, you are relying on something most people never think about: electricity. Behind every data center is a highly engineered electrical system designed to deliver one thing above all else: continuous power. Because in a data center, even a few seconds without electricity can shut down thousands of servers, interrupt businesses, and cost millions of dollars. So how do data center electrical systems actually work? In this video, we're going to break the system down into 3 key ideas that explain how these facilities keep power flowing reliably to the servers that run the digital world. By the end of the video, remember these 3 things. First, data centers use multiple layers of power infrastructure to distribute electricity safely. Second, they include instant backup power systems to prevent even momentary interruptions. Third, everything is designed with redundancy, so a failure in one component doesn't shut down the entire facility. Let's start with the first concept. Data centers use specialized electrical distribution systems that are built to handle enormous and constant power demand. Inside a large data center, electricity arrives from the utility grid at medium or high voltage, often between about 13,000 and 35,000 volts. This high-voltage power enters the facility through electrical service equipment and then passes into switchgear. Switchgear is one of the most important pieces of electrical equipment in the entire building. It acts as the control center for incoming electricity. It allows operators to isolate circuits, redirect power flows, and protect the system using breakers and protective relays. From switchgear, the electricity moves into step-down transformers. Transformers reduce the voltage to levels that are more suitable for the building's electrical systems. For example, the voltage may be stepped down to 480 volts, which is commonly used for large equipment and electrical distribution systems inside commercial buildings. From there, power flows into power distribution units, often called PDUs. PDUs take that 480-volt power and convert it again to voltages used by server equipment, such as 208 volts or 120 volts. Finally, the electricity travels through branch circuits and rack power strips that supply power directly to individual servers inside the racks. So the electrical path inside a data center is essentially a series of controlled voltage transformations and distribution steps, moving power from high-voltage utility supply all the way down to the sensitive electronics running inside the servers. But simply distributing power isn't enough. Data centers must also protect against interruptions. This leads to the second critical concept: backup power systems. Unlike most buildings, data centers cannot tolerate even a brief power outage. A momentary interruption might reboot thousands of servers and disrupt services around the world. To prevent that, data centers rely on uninterruptible power supply systems, commonly called UPS systems. UPS systems act like massive electrical batteries. When utility power is flowing normally, the UPS conditions and stabilizes the electricity before it reaches the servers. But if utility power suddenly fails, the UPS instantly switches to battery power. This transition happens so quickly that servers never see an interruption. The UPS system keeps the servers running long enough for the next layer of backup power to start. And that brings us to the large engines you often see outside data centers: backup generators. Most large data centers use diesel generators that can produce several megawatts of power. When utility power fails, these generators automatically start and typically reach full output in less than a minute. Once the generators are running, they take over the electrical load and continue powering the data center for as long as fuel is available. Some facilities store enough fuel on site to operate for many hours or even several days. With fuel deliveries, they can run even longer during major outages. This layered approach, utility power, UPS batteries, and backup generators, ensures that servers continue running even during major electrical disruptions. Now let's look at the third key concept: redundancy. Redundancy is one of the most important design principles in data center electrical systems. Instead of relying on a single piece of equipment, data centers often install duplicate systems. For example, a facility might have 2 independent electrical feeds from the utility grid. It may also include multiple UPS systems, multiple generators, and multiple electrical distribution paths. This means that if one piece of equipment fails, another system is already available to carry the load. Some high-reliability facilities even design the electrical system so that entire power paths are duplicated, allowing maintenance or failures to occur without interrupting operations. You may hear these redundancy strategies described using terms like N, N+1, or 2N, which we discussed in our earlier video on redundancy design. The goal is simple. No single failure should ever take down the data center. When you combine layered power distribution, instant backup systems, and redundant electrical infrastructure, you end up with one of the most reliable electrical systems ever built. And that reliability is essential, because inside a large data center, tens of thousands of servers may be processing information every second. If power stops, the digital services those servers provide stop as well. So while servers and cooling systems often get the attention, the electrical infrastructure is what makes the entire facility possible. Without it, the internet as we know it simply would not exist. In the next video, we're going to take a closer look at one of the most critical components we mentioned today: UPS systems. We'll explain how UPS systems work, the different types used in data centers, and why they are essential to maintaining uninterrupted operations. If you want to understand how the digital world stays online 24 hours a day, UPS systems are a key part of the story. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.